welcome to the channel. Here we are going to continue from where we stopped on intersection of solids, as we have looked at the first two videos, and this is the third one in which we have two cylindrical pipes with unequal diameter. One is vertical and the other is inclined, as you can see here on the screen. So let's talk about the dimensions on the diagram, on the figure, before we go on and work out what we are to do here. So we have that the diameter of the circular base of the vertical cylinder is 46 millimeters, its height is 90 millimeters, and then for the inclined cylinder, so we have the diameter of its circular end is 32 millimeters, and the length from this end to the center here to this point here is 70 millimeters. The center line of the inclined cylinder is at angle 45 degrees to the horizontal, and this point that the center line of the inclined cylinder touches the center line of the vertical cylinder is for 15 millimeters from the base. So we are going to make use of these dimensions to produce the plan and also the front elevation with the curve of intersection on the front elevation here. So that's what we are going to do right now. So let's go and see what we are to do. Now the first thing that we are going to do is to draw a vertical center line. So I'm going to draw a vertical center line here. So we have a vertical center line. So don't forget that our center line is drawn with thin long chain line, as you can see me doing it here. So we have to bring this down a little bit. So here we have it here. So then we are going to draw a horizontal center line. So we draw horizontal center line. So we have the horizontal center line going like this. Okay, so we have it here now. So the next thing that we are going to do is that, as we have that the diameter of the circular base of the vertical cylinder is 46 millimeters, so 46 by 2 will give us 23 millimeters. So this is 23 millimeters here. So we put pinpoint here where the two lines intersect, and we are going to draw a circle. So we draw this circle. So here we have a circle like this. Okay, so this is a circle. Okay, so we have it here. So the next thing that we are going to do is to draw the elevation of the vertical cylinder. So we come up a little bit here and we draw a horizontal line. Okay, so with the set square at this point on the circle, so we are going to draw a vertical line. So we are going to draw a vertical line. So from this point, so we draw a vertical line here like this. Okay, and then so coming to this side at this point on the circle, so we're also going to draw a vertical line. So here we have a vertical line here. So now we are going to take 90 millimeters, which is the height of the vertical cylinder. So 90 millimeters, the height of the vertical cylinder. So this is 90 millimeters here. Okay, then we are going to draw a horizontal line. So through this point, so we have the horizontal line like this. Okay, so now, so let's go and work on the inclined cylinder. The first thing that we are going to do, as we have that the center line of the inclined cylinder touches this line at a distance of 15 millimeters from the base. So first of all, take a measurement of 15 millimeters from the base here. So this is 15 millimeters. Okay, then we know that the center line of the inclined cylinder is at angle 45 degrees to the horizontal. So we have to take a 45 degrees set square. So bringing it to this point here, so bring it to this point on the vertical center line of the vertical pipe. Okay, so and then we draw a center line in this direction. We draw center line in this direction. So here we have the center line. The next thing that we are going to do is that, as we have here that the length from this point to this end of the inclined cylinder is 70 millimeters. So we are going to take a measurement of 70 millimeters from this point. So where the center line of the inclined cylinder touches the center line of the vertical cylinder, so we are going to draw we are going to take a measurement of 70 millimeters. So this is 70 millimeters. So the next thing that we are going to do is that we are going to draw a perpendicular line to this line. That means a line that will be at a right angle to this center line. So since the center line is drawn with 45 degrees, so we are going to make use of 45 degrees set square to draw a line that be at a right angle to the center line of the inclined pipe. Okay, because 45 plus 45 will give us 90 degrees. So here we draw this line. So we draw this line of any length. So it's at a right angle to the center line here. So the next thing that we are going to do is this. So since we know that the diameter of the circular end of the inclined pipe is 32 millimeters, so we are going to take a measurement of 16 millimeters, which is half of 32. So we take a measurement of 16 millimeters. So here is 16 millimeters here. So here we have 16 millimeters. So at this point we are going to draw a semicircle. So we draw a semicircle here like this. So here we have a semicircle. Okay. So here we have a semicircle, and this semicircle we are going to divide into 6 equal parts. So just put at this point. So then draw an arc. So put it at this point here, at this point. So you put at this point, and you draw an arc to this side, and draw an arc to this side here. Then we put it at this point here, at this point. Okay. So where the semicircle touches the line, so we draw an arc. So let's keep this 16. Let's keep it here because we need to do the same thing here, but I want us to extend this line a little bit. Okay, let's extend this center line a bit to this side. So we have it here like this. Okay, so the next thing that we are going to do is that we are going to move away a little bit from here, and then we are going to draw okay, so let's do it this way. So let's do it this way. Now I want to save the space that we have on this paper. So what I'm going to do now is that from this point I'm going to draw a line from this point, but I'm going to make it a thick line at once. So I'm going to make it a thick line at once. So draw this line from here to touch this side of the pipe. Okay, and then come to this point here. So come to this point, and also so we draw a line from this point to touch this side of the pipe. So we leave it like this. Okay, so for other point that we have, so let me first of all label the point on this. So I'm going to call this point, this is point 0, this is point 1, this is point 2, and this point I will call it 3. So this is 2, this is 1, and this is 0. So now, so with the same 45 degrees square, we are going to draw a line from point 1, and this line is going to be a thin continuous line. So I usually use my red pen for that. So draw this line into the pipe, and at point 2, so draw a line into the vertical pipe, and then from point 2 here draw a line into the vertical pipe, and then from this point 1 draw a line into the vertical pipe. So let's leave this for now. So then the next thing that we are going to do is that we are going to draw a line from each point that we have here. So not on the semicircle, but on this line. On this line. So what I mean is this. So with my set square being set at point 0, so I'm going to draw a vertical line from that point 0 down here. Then from point 2, from point 1, I will also draw a vertical line down. And then from point 2 here, I will draw a vertical line down. So from point 3, so we are going to draw a vertical center line down. A vertical center line down here. Okay, so draw it down. Then from point 2 here, so we also draw a vertical line down. So from point 1, we are going to draw a vertical line. Okay, and from point 0 here, we are going to draw a vertical line. So having this now, so the next thing that I'm going to do is that we are going to move away a little bit. So just move away a little bit from here. Okay, then we are going to draw we draw a vertical center line like this. Okay, so I will have made use of this line, but I don't want them to be together. I want them to be separate. So that's why I drew this line. So with that same 16 that we have here, so put the pinpoint here and then draw a semicircle. So draw a semicircle here like this. Okay, so we have this semicircle. So we are going to divide this semicircle into 6 equal parts as we did here. So we put at this point, we draw an arc. So put it at this point here. Okay, so we draw an arc to this side, and then we turn it to this side, we draw an arc. Then putting it at this point here, so putting it at this point here, so we draw an arc here. Okay, so we are going to number the point that we have on this semicircle, but we are going to change the numbering unlike the way we numbered it here. This is what we have to do. So this point now, I will call it 0. So this is 1, this is 2, and this is 3. You have to change the numbering. Then this is 1, this is 2, and this is 3. So you must number them differently. So by doing that, that will enable you to get the curve of interpenetration or the curve of intersection on the front elevation. Okay, so what we are going to do now is this. So from this point 3 here, I'm going to draw a horizontal line. So I will draw a horizontal line from this point 3 to touch the circle, and then I will come up here from point 3 up here. I will also draw a horizontal line touching the circle at this point. Then the next thing that we are going to do is that we are going to draw a horizontal line from this point to here. Okay, and that's going to be drawn within continuous line, so which I usually use my red pen to do. Then we come up here, so we also draw a horizontal line from this point to touch the circle. Then we come up here, so we also draw a horizontal line from this point touching the circle. Then coming up here to point 2, we draw a horizontal line touching the circle here. Alright, so with what we have here now, there's something that we need to do here, but before I do that, so I want us to bring out the thickness of the edges of the vertical pipe. Okay, so we make this line a thick line. So we have to make this line a thick line, and then for this line here, so from this point to this point, we make it a thick line, and from here to from this point to this point, we make it a thick line, and then this chop of the vertical pipe, we also make it more visible, so we make it a thick line, and then here also we also make this base, we make it a thick line. And for the inclined pipe, so it's only this line, apart from the ones that we have made the thick line, so we also need to make this one, we need to make it a thick line like this. Okay, so with this, so we can proceed. Alright, so now when I'm looking at this, the whole of this down here, I'm going to see a circle on this part, on this end of the inclined pipe, and by looking at it down, I need to see that circle here in the plan. So this is the plan of the inclined pipe, while this circle is the plan of the vertical pipe. So we only see a circle over here, and that's what we have done here. But in the case of the inclined pipe, so the circle that we see here, we need to make use of these lines that we have generated here to bring out that circle, but it's not going to be a normal circle, it's going to be an ellipse. Let's look at how we can get that done. Okay, so the purpose of drawing vertical lines here that intersect this horizontal line is for us to bring out that shape, and let's look at how it goes. Now this is line 0, so if I follow this line, this is line 0, and it intersects this line 0 at this point. That's why I say you have to number differently. If you number them in as you numbered here, you'll not be able to work this out. Okay, so you must number differently, so pay attention to that. So from this 0, so this line 0 here, vertical line 0, intersect horizontal line 0 at this point. So we take note of this point here. So we take note of this point, and we also have 0 on this side, so we also take note of this point here. Okay, so then the next is 1. So vertical line 1 and horizontal line 1, they intersect at this point, and don't forget that we also have 1 on this side, they intersect here. We also have 1 on this side, they intersect here. So 1 on this side, so we also have 1 here, so they intersect at this point here. So let's take note of that. Then for 2, so this is vertical line 2 coming down here, so it intersects horizontal line 2 at this point. Okay, we also have 2 on this side. So coming down here, we have 2 at this point, and we also have 2 at this point here. So let's take note of that. Okay, next is 3. So coming down here, so it intersects this horizontal line 3 at this point, and it also intersects it here at this point. So we have the point now. So all these points, we are going to join them together for us to get the shape that the circle here will look like in the plan. So what it will look like in the plan. So we have to bring that out now. So let's quickly work that out. So starting from this point, I'm looking at the part of the French curve that I will use to bring out that curve. So that is what I'm doing here right now. Okay, this will work perfectly. So all I have to do is to join them together like this. So now just take your time. So we join them together as we have here like this. Okay, so we have this now. All right, so we just need to take our time to work this out. Okay, so that is what I'm doing. So coming down here, so let me just do the same thing at once. So we join this together like this. Okay, so we have this. Okay, so then I can easily join this together. Easily join this together like this. Okay, so we have this now. So and finally, so on this side here, so I will also do the same thing by joining these 2 points together. Joining these 2 points together like this. All right, so we have it now. So this is what the circle here, when we're looking at it down, so this is what is going to look like. Okay, so we have this as the plan of this. So we have the plan here. So okay, so now, so this is not supposed to be part of it. So I'm supposed to clean from this point here and from this point here. So the plan is just from this point touch to this point on the circle, and from this point to this point on the circle, but I'll just leave it like that for now. Now let's go and work on the curve of intersection on the front elevation of the 2 solids. So let's do that. So what we have to do now is that, so with my t-square being set here, I will take the set square. Okay, so here we have what? Here we have, so this horizontal line 1 that we have here in the plan, it touches the circle at this point. And if you look at it, we have already drawn a vertical line from here up, and it intersects this inclined line 2 at this point. Sorry, the inclined line 0 at this point, and also inclined line 0 at this point. So we take note of that. Okay, now, so next is 1. So we have the horizontal line 1 touching the circle at this point here. Okay, so from this point, we are going to draw a vertical line. We are going to draw a vertical line. So for 1, so we draw a vertical line from here, and it goes up like this. Okay, so this vertical line 1, it intersects or inclined line 1 at this point. So we take note of this point, and also we also have 1 up here, intersect at this point. And then, so then for 2, so it touches the circle at this point. So from this point here, we are going to draw a vertical line. So we draw a vertical line at this point. We draw a vertical line at this point here. Okay, then we have that this vertical line 2, it intersects inclined line 2 at this point. So we have this point, and also we also have 2 here. So we have this point, they intersect here. And lastly, for 3, so we are going to draw a vertical line 3 from this point where the line touches the circle. So we draw a vertical line up. So this vertical line 3, it intersects inclined line 3 at this point here. So we take note of this point. So what we are going to do now is to join the point together for us to obtain the curve of intersection on the front elevation. So what we do now, so with the French curve being set along this point, okay, being set along this point, so we need to make sure the curve comes out very well. So I will join this point together like this. Okay, then at this point, okay, so I'll just turn, then we can join this point together. Okay, then coming down here like this, so we join this point, we join them together like this. Okay, so here we have the curve of intersection, as you can see here, or curve of interpenetration, as you can see it here like this. Okay, so we have it here. So as simple as I've done it here. And don't forget that in this case, we have 2 cylindrical pipes that are of unequal unequal diameter. So the diameters are different. Okay, so let's pay attention to what we got here, because the next one that we are going to look at is that of the equal diameter, when the 2 pipes are of equal diameter. So let's meet on that video. Thank you, keep on practicing, and God bless you.